And now we're happy. And so now I can say let compare 1 and 2 equals to 1 less than 2. And thus I have introduced a new operator into the language. Now the language, as I said, it doesn't care. It doesn't think of it as an operator. It just thinks of it as a method with a really funny looking name. Okay? But this is one of the advantages we start to get into when we start talking about being a little bit more flexible with our syntax and sort of opening it up and saying, you know, the only difference between plus and the word add is a couple of characters. Let's do away with that completely. Let's open this up and allow people to create their own syntax as necessary. And as a matter of fact, F# uses this exact form to define all of its basic operations, including mathematical operations. The language is literally defined inside of itself, which is very powerful. Scroll a little bit further down just to see some more functions, because one of the key things about a functional language is that we use functions as a first-class concept. So the last concept I'm going to leave you with here is the idea that if I want to, given a list of numbers, if I want to generate the squares of all of those numbers, again, how would you do it? Traditional C# imperative programmer says, for each across the list, generate the square of that number and store it to a new list. In a functional language, because functions are values, and we think of them in first-class concepts, what I can do is I can use the built-in function called list.map. The map function says, give me a function to call and a list to iterate over. And I will map your function on top of each of those list elements to generate a new list. Now, at the heart of it, you're probably thinking, why is this any easier, quote unquote, than just doing a for each through the list? I mean, come on, right? How is this any better? I could just as easily, and it would arguably easier to read, particularly if you're coming from C# or VB, just as easily walk through that iteration. I mean, I've saved myself, what, maybe a couple of characters of typing. What happens when we decide that this list, which here is just 4 elements long, what happens when we decide that, you know, instead this list should be 10,000 elements long? And it turns out that we're not just calling the squares. What I want to do is I want to compute some very large and heavy mathematical function on top of it. To do all of that on top of one thread will take how long? What if I want to break this up across multiple threads? What if I want to calculate these guys in any particular order? I don't particularly care the order that the results come back in, but I want to take advantage of the CLR thread pool. How much work are you going to have to put into your for each loop? And what's even worse, you're going to have to do this every time you want to do this for a given list of numbers. Here, I can create a parallel map function. We'll call it pmap. And inside of there, the iteration and the calculation, the square function, can be called on a separate thread, harvest the results, concatenate it back to the list, et cetera, et cetera. And you, the programmer who makes use of it, you just, instead of saying list.map, instead you say list.pmap. And suddenly you've implicitly become multi-threaded. Now, there's a compelling reason to think about doing things in this style. How many people have started playing around with Link, Microsoft's Link? Have you looked at the parallel extensions to Link? Did you notice some similarity between that and this? There's a reason for that. There's a lot more to this language than what I've shown you here. I mean, there's still some more stuff further on down just in the tutorial itself. And as I said, there is definitely no way that I can teach you a programming language in just 60 minutes. But hopefully at this point, you're starting to see a little bit of why people are getting interested in F# and what actual, you got someplace to be, man? Yeah. Oh, okay. His lecture? Oh, is Neil lecturing? Do I have to stop now, Anna? Yes. Okay, I'll stop. Just let people ask questions. Does anybody have questions? Well, there's a couple of answers to that concern, right? I mean, you got so many different developers, and they could introduce their own operators and so forth. That's true, right? And the one answer says, when you go to the doctor and say, doctor, it hurts when I do this, the doctor will tell you, well, don't do that anymore, moron. You needed to be told this, but, thank you. The applause for my bad joke. I mean, seriously, right? The key thing here is to understand that flexible syntax is both, it's power, right? And as we learned as small children, reading the comic books, with great power comes great responsibility, right? So you just have to learn to use this correctly. Because you could screw yourself over in C#. You're just going to do it in different ways. Okay? Okay, I think I'm done now.
Very good. Thank you very much. We have a gift for you, of course.